Hi, welcome to one and all. Next, we will be discussing about the further properties of induced moduli. So we have the theorem which states the property that chi be a Dirichlet character mode k and assume d divides k, d greater than 0. Then d is an induced modulus for chi if and only if chi of a is equal to chi of b whenever GCD of AK is equal to GCD of BK, which is equal to 1, and A is equal to B mod D. So we have to prove that if D is an induced modulo for chi, we have to prove that this condition equation 16 is satisfied, and if this equation 16 is satisfied, we have to prove that D is an induced modulus for chi. So first we suppose that this 16 is satisfied, then we have to prove that D is an induced modulo. So first we suppose that 16 holds. That is, for chi of a, we have chi of a equal to chi of b whenever GCD of AK is equal to GCD of BK is equal to 1 and A is equal to B mod D. Then the proof is very simple, because if we put B equal to 1 here, then chi of 1 is actually 1. So this chi of a will become equal to 1, and whenever GCD of AK is equal to GCD of BK will become 1k, which is 1. So GCD of AK is 1 and A is equal to 1 mod D. This is actually the definition for the induced modulus. So D is clearly an induced modulus for chi. Thus D is an induced modulus. Now the converse part. So we have to prove the converse part. Here we will assume that D is an induced modulus. Now to prove that chi of A is equal to chi of B, we have to, in case of this condition, we have to assume this condition. So for that, we will assume that, first we assume that D is an induced modulus, then choose A and B so that GCD of AK and GCD of BK is 1 and also A is equal to B mod D. Then what we have to show is chi of A is equal to chi of B. Now since GCD of AK is 1, so we can find a inverse, multiplicative inverse mod k for this A. So we take it as A prime. A prime is the reciprocal of A mod k. Then we have clearly, by the definition of the reciprocal, we can see that A prime is equal to 1 mod k. Then the reciprocal exists because GCD of AK is 1. Now clearly you could see that since A prime is congruent to 1 mod k, and we have already studied ourselves that if some x is congruent to y mod k, then and if d divides k, then x is congruent to y mod d also. In the same way, this A prime is congruent to 1 mod d and d divides k. So we can clearly write A prime is congruent to 1 mod d. Since d is CD is a divisor of k. Now if also we know that this GCD of A prime k is also 1, because GCD of AK is 1, A prime k is also 1, so A prime k is also 1. Thus we have the condition for we can apply that condition here, that is GCD of A prime k is 1, A prime is equal to 1 mod D, it is also there. So clearly chi of A prime is 1. So that shows that because that is 1. Why? Because D is an induced modulus. Now we know that what is A prime. A prime can be congruent to B A prime, which is congruent to 1 mod D, because A is congruent to B mod D, that we have assumed earlier. We have first assumed that A is congruent to B mod D. So this is by using the result. If x is congruent to y mod k and z is any integer, then xz is congruent to yz mod k. So same way here, A prime is congruent to 1 mod d, and also A is congruent to B mod d. So A prime is congruent to B A prime, which is congruent to 1 mod d. So by using this result, what we can see is that chi of A prime is equal to chi of B A prime. Chi of A prime is equal to chi of B A prime. Chi is multiplicative, so we can write it as chi of A prime, which is equal to chi of B, chi of A prime. Now, since chi of A prime is not equal to 0, since chi of and also chi of A and chi of A times chi of A prime is 1, so we can cancel this chi of A prime from both sides, and we will get chi of A is equal to chi of B, which we have to prove. So we have proved that chi of A is equal to chi of B. Thus, we have proved the result. Now, what equation 16 tells us is that chi is the periodic mode D on those integers relatively prime to k. That is, chi acts very much like a character mode D. That is, as D is a induced modulus, we can see that this instead of character mode k, we get this chi as character mode D. That is what the theorem tells. So on those terms, we have chi of A is 1. So that is the reason. Now we can illustrate that using an example. Let us consider the Dirichlet character mode 9. So this is the Dirichlet characters mode 9. Now we will take this chi 4. If you take this chi 4 as one Dirichlet character, that the following table describes one of the character chi mode 9, that this character, if you take this, you could clearly see that this is periodic modulo 3. This is periodic modulo 3. And so we can say that this is 3 is an induced modulo for chi. Why? What is mean by induced modulo? For any numbers with this condition. That is, whenever GCD of AK is 1 and A is content to 1 mod D, we have chi of A is equal to 1. This is the condition. If this is satisfied, then we say that D is the induced modulo. So if here 3 is a divisor of 9, also 3 is a divisor of 9. Also, if you take any number with the 3, you could see any number with the 3 as the divisor, you could see that those numbers we will get chi of A. That numbers which satisfies this will have chi of A is equal to 1. So in that case, we could see that 3 is an induced modulo for chi. But here you can also see that chi acts like the following character. Suppose if you have a psi mode 3, then what is psi mode 3? Psi mode 3 is psi of n, where the character will be having 1, -1, 0. So this is something like sin mode 3. If you have sin mode 3, you can generate all the other terms, because psi of 1 is 1, psi of 2 is -1, psi of 3 is 0. Again, psi of 4 will be like psi of 1. So it will behave like psi of 1. Again, psi of 5 will be like psi of 2. So it will be like here, and psi of 6 will be like psi of 3. So here, so this clearly, this chi of n will be an extension of this psi of n. So we can say that since chi of n is equal to psi of n for all n, which are chi an extension of psi. So it is clear that whenever chi is an extension of a character psi modulo d, then d will be an induced modulo for chi. So we have already found that d is here 3 is an induced modulo for chi, and after that we have seen that chi of n is equal to psi of n, where chi is an extension of this psi. But we have to now check whether the converse part is true. That is, then whenever chi is an extension of psi, then d will be an induced modulo for chi. Now we have to check whether if d is an induced modulo for chi, then all the time chi of n is an chi is an extension of psi. But this is not true. The converse part is not true. For that we will take another example. Consider another example. Consider the table for Dirichlet characters mode 6. So for that you could see that this is the Dirichlet character mode 6. We will take this chi 2 of n as our chi of n. we are taking one Dirichlet character. Here also you could see that the divisors of 6 are 3. Okay, so 3 is a divisor. Now we want to check for less than 3 whether chi of n is 1 for all n with which is less than 6. Okay, so here for that condition, for our condition that n congruent to 1 mod 3 and chi of n is equal to 1, we have only one candidate, or GCD of n6 is equal to 1, we have only one candidate, that is 1. In that case chi of n is 1. So only one candidate is there for that. So clearly this 3 is an induced modulo for this chi. But so chi is, but here you cannot say that chi is an extension of psi modulo 3, because what is the reason is because what is the reason for this? This is because here you will not get 4, 5, 6 as the extension of this psi, or this psi 1, which is a principal character. So we will not get principal character. So we will not get this as chi of n as an extension of this psi. So we cannot generate the other terms, because psi of psi of 1 is 1, psi 1 of 1 is 1, psi 1 of 2 is 1, psi 1 of 3 is 0. Here psi 1 of 1 is chi 1 of 1 is 1, chi of 2 is 0, and chi of 3 is 0, and chi of 4 is 0. So this cannot be generated from this, since chi of 2 is 0. That is the reason. So this cannot be an extension. So what we have understood is that even though D is an induced modulo for chi, we cannot say that chi will be an extension of psi. But if we can find a psi which is an extension of, we can find a psi such that chi is an extension of psi, then clearly there will be this a D such that D is an induced modulo for chi. That is what from these two examples we can understand. I hope you have understood this, and by using this result we are going to prove a theorem which we are going to prove next. Hope you have understood this clearly. Thank you for your patient listen.